Hello everybody. I guess you hear me well, right? So it is a great honor for me to be here today to share with you some of the results of my activities both at the Center for Digital Music at Queen Mary University of London and at Mind Music Labs. Mind Music Labs is a company that I have co-founded. It's based in Sweden, in Stockholm, and basically deals with the creation of new technologies for musical instruments. We live in a connected world, don't we? Everybody wants to be connected with everybody at any time and everywhere. This is basically the result of the so-called Internet of Things. Internet of Things is an umbrella term which refers to the extension of the Internet to the physical realm by means of objects that are things that are capable of sensing the environment, collecting information from it, and communicating wirelessly this information to the Internet. There has been a lot of progress about Internet of Things technologies in the past years. However, when it comes to music, the situation drastically changes. Indeed, to date, the application of Internet of Things technologies to the musical context have received remarkably little attention in both the industry and in the academy. Compared to other domains like healthcare, smart cities, even fitness. On the other hand, musicians are clearly showing new needs. The need of creating, recording, and sharing music, indeed, is growing exponentially for the musicians. They want to communicate and share their music at any time and anywhere, like all the other class of users of Internet of Things technologies. Smart experiences, however, are today still very limited for musicians. Why this happen? One of the possible reasons, speaking only about the technological perspective, is simply a lack of an Internet of Things technological infrastructure that is capable of supporting interactions of the musicians over the net. Basically, musical instruments are missing today, which are capable of connecting to the Internet and communicating with each other and other smart devices. On the other hand, also our connectivity infrastructure is missing, which is appropriate for supporting musical interactions. Indeed, music poses strict requirements compared to the Internet of Things domain. These requirements basically are ultra-low latency and high-quality communication in order to achieve realistic multimodal musical experiences over the network. There are also synchronization mechanisms that are fundamental for musicians in order to communicate between each other, which are not really there yet in the Internet of Things technologies available nowadays. So I'm here to propose to you what we call as an Internet of Musical Things, which is an emerging field in music technology that basically lies at the intersection of different existing fields, like music technologies, in particular new interfaces for musical expression, artificial intelligence, Internet of Things, of course, and basically, we see the Internet of Musical Things as a subfield of the more general field of Internet of Things. The Internet of Musical Things relates to the network of physical objects that we call musical things, indeed, which are dedicated to the production, interaction with, or experience of musical content. Like in the Internet of Things, there are things. In the Internet of Musical Things, there are musical things. What are musical things? Well, basically, a musical things can take different forms. It can take the form of a smart musical instrument. That is one of the topics that we'll introduce to you in a bit. A wearable, like the musical Haptic wearable that I will define also in a bit, or any other smart device that is utilized to control, generate, or track responses to musical content. This might be, for instance, your smartwatch or a phone, even a headset for virtual reality, or other devices that are not available today on the market. What are the main implications of this paradigm of Internet of Musical Things? Basically, ecosystems that are based on Internet of Musical Things technologies, hardware and software technologies, like platform, for instance, can support new types of interactions between the various actors, the various stakeholders, particularly musicians and their audience. Today, as I said, I will present also this new class of musical instruments that are the smart musical instruments. Also, we'll talk about musical haptic wearables, that are a new family of wearables that is basically leveraging the sense of touch in order to achieve novel types of creative communication within the Internet of Musical Things. I'm going to show you a video of the first smart musical instrument that has been developed by my company, My Music Labs. This is the Sensus Smart Guitar. So, Sensus, as you see, is a real instrument, it's not a toy. It's a real guitar in its own right. It's basically built according to the crafting techniques of the Stradivari school. The Stradivari school is a school based in Italy, in Cremona. Is very well renowned for the crafting techniques that have been originating indeed for the construction of violins. And basically it's a guitar augmented with different sensor technologies, like have you seen there were pressure sensors or proximity sensors that were tracking the gesture of the hand of the performer, in particular the distance of the hand from a certain place, a certain spot in the instrument. And the guitar is also a 360 degrees hi-fi sound system, because we are able to alter the vibration of the soundboard by means of a system of multiple actuators. As you were seeing in the video, there were no loudspeakers indeed involved. It was the guitar that was delivering the electronically generated sounds. And moreover, Sensus is a true Internet of Things device. It enables Wi-Fi connectivity, Bluetooth, and also connectivity to the Internet. It can also stream audio signals. It has connectivity options also with normal channels like cables, and can also communicate various types of control messages, such as MIDI or open sound control messages. But what are smart musical instruments? Smart musical instruments are fundamentally resulting from the holistic integration of different types of technologies, such as Internet of Things technologies for communicating via wireless, embedded systems that are dedicated to audio, but also all the sensors and actuators that are embedded in a smart musical instrument in order to achieve the extension of the sonic possibilities of a musical instrument. In particular, this extension, as you have seen in the video, concern of the tracking of the gestures of the performer and mapping these gestures into different parameters of a sound engine that is running onto the embedded system. What are the core differences from other interactive performance systems? Basically, that a multitude of equipment is not needed. In a typical performance settings involving electric guitars, you will have the amplifier, you will have a bunch of foot pedals that are used by the guitarist to modulate the sound. We have brought all this equipment inside the guitar. This means that we are leveraging on digitalization of analog devices, of course. And all this software runs on an embedded system that is dedicated specifically for the processing of audio, for the processing of sensor signals, and is dedicated to the wireless communication of various types of information that are sensed by the instrument itself. All these components are indeed embedded in a same musical instrument. The processing, as I said, is done inside the musical instrument and not anymore outside it, like it happens in many experimental music context where you have, for instance, a conventional acoustic instrument, a sensor interface placed on top of it, but all the processing is done outside the instrument. Smart musical instruments are capable of directly exchanging musically relevant information between each other. By design, they are interoperable. And also, they are capable of communicating with a network of connected devices, and not only are capable of delivering multimodal information to external equipment, but also are capable of receiving, processing, and displaying it to the player. Smart musical instruments enable different types of interactions with the performer, between performers, and between performer and their audience. Basically, example of applications can fit in two categories that are the enhanced creative content creation and delivery, and also the exploitation of feedback from the audience. I'm going to give some concrete examples that have been studied both in the academia and the industry. Concerning the Sensus smart guitar, it is possible, for instance, envision some types of multisensory performances where the instrument itself is capable of delivering control messages to stage equipment, such as light or smoke machines or visuals that are displayed on screens. So while the musician is expressing himself or herself musically, also there is another layer of multimodality that contributes to the performance. Another example is when it is enabled by this type of technology is a collaborative music making over a network. In this case of this picture, over a collocated a local network where there are three musicians, one of which is playing a smart musical instrument, and the other are using smart devices that control parameters of the sound engine that is embedded inside the instrument itself. So basically you can control a drum machine, a loop station, and so on. That is running inside the same musical instrument while the musician is actually playing. Another use case concerns the use of smart musical instruments in conjunction of headset for virtual reality. So basically, the smart musical instrument can send control messages to a visual, to a virtual scenario that will be visually displayed by an Oculus Rift, for instance, headset. And at the same time, for instance, the user of this virtual reality headset can control some aspect of the musical performance by means of interacting with the virtual world. Another use case consists of playing together with your favorite artist, for instance, where your favorite artist can play with you on the same smart musical instrument by accessing content that is present on the cloud. So you can stream in real-time content from services like Spotify and play over it, and at the same time you can record all this content in hi-fi quality, and then at the cost of one click deliver it back to the cloud, for instance, to share it over Facebook or over SoundCloud or other social networks. In order to achieve all I said, you need a technological infrastructure that is capable of supporting these interactions. At My Musical Labs, we have developed ELK. ELK is a music operating system that guarantees ultra-low latency audio and sensor processing. Also, it's based on Linux, so it has all the flexibility of an operating system like that. In particular, natively, it supports connectivity. For instance, it supports connectivity to Bluetooth, Wi-Fi, and also connectivity to 4G. A peculiarity of this novel music operating system that constitutes nowadays the state-of-the-art for technologies enabling the Internet of Musical Things is it's being platform independent. So basically, thanks to efficient development tools, developers can code the software and make it run over a different range of embedded systems based on different types of architectures. All these enable the creation of smart musical instruments and products that are embedding ELK started to emerge. One example is, for instance, the smart multi-amp that is developed by an Italian company called DV Mark. Smart musical instruments can connect with musical haptic wearables that are a novel class of wearable devices. Basically, these devices are capable of encompassing haptic stimulation, are capable of tracking gestures and physiological parameters like the heartbeat, and wirelessly connecting with the other smart devices in order to communicate the sensed information. They were conceived to enhance creative communication between musicians as well as between musicians and their audience by leveraging the sense of touch in both co-located and remote settings. On the other hand, smart musical haptic wearables were conceived to enrich musical experiences of audience members in live performance by integrating haptic stimulation as well as providing new capabilities for creative participation thanks to a sensor interface that allow the audience member to deliver content to the performance, for instance. So the audience member become actively part of the creation process. We created some example of musical haptic wearables, and I want to share with you a video of what we created. And tested in a experimental context. Basically, This is a wearable that encompasses 2 motors that provide tactile feedback. It has wireless connectivity and has some buttons that allow the user to communicate wirelessly some type of information. This video shows 2 electronic music performers where there is a conductor and a receiver, another performer, that will react wirelessly to a certain type of vibration that encoded a certain type of information. In this case, change section slowly. In a bit, you will see indeed that the musician acts slowly on the parameters of his own digital musical instrument to change its own musical style. The musician, the conductor, will also deliver another type of information. Here you go. You touch the button. In this configuration, instead the musician has to change section rapidly. You can encode different types of information like stop playing, start playing, modulate the volume, and so on. It's a new type of communication that is basically enabled by these technologies. Okay, I can share with you the result of a scientific investigation that basically are all pointing towards the conclusion that this kind of communication that leverage the sense of touch are feasible and effective. And another example of this communication that can be supported by musical haptic wearable consists in the application of these tactile devices in electronic music performances or other music performances, where instead of the performer is the audience member that is wearing these devices. And basically there is an issue in electronic music performance, because when you see an electronic music performance, musicians are acting on tiny controllers, tiny knobs and faders and so on, that are typically not visible by the audience. Also, the relation between the performer gesture and the sound that is produced is totally arbitrary, and this is largely differing by the example of conventional instruments in which, for instance, a guitar, you see a musician playing a chord, and you hear at the same time the sound. This relationship between gesture and sound is lost in electronic music performance. So, thanks to this haptic wearable, we wanted to restore this communication and this understanding. We did some experiments, and basically one can conclude that based on the observation that we gathered, that these forms of communication based on the sense of touch are capable of enhancing the audience connection with the performers, and as well as the engagement of the performer with the music. I would like to conclude by having some reflections about the theme of the conference, that is music and sovereignty. As far as smart musical instruments are concerned, well, smart musical instruments have the power of being easy to carry. As you don't need to bring anymore all the foot pedals that a musician needs to bring in order to modulate its sound. But also, smart musical instruments are smart devices. They are capable of being upgraded and updated. And all these enable a more ubiquitous use of music technologies. Moreover, there are pedagogical implications, because smart musical instruments are capable of collecting a multitude of data from the performer act of playing. And this data can be used in different ways, like for instance for envisioning types of learning or music learning that are novel and might be, for instance, based on artificial intelligence techniques. All this, of course, poses some types of issues like privacy and security, which are issues that are common also to the more general things of more general field of Internet of Things. Thank you very much. If you have any question, I would be very happy to tackle them. These are the websites that I recommend you to have a look at. One of my music labs, my company, and the other is the website of my project that is supported by the European Commission. Thank you. Yeah?
Are there any questions that would like to be asked now?
Thank you. Hi.
Hello?
The question I have, you mentioned briefly about using artificial or augmented intelligence to, play instruments or to analyze playing styles or things like that, and how you see that evolving. Because how do you tell the difference now between the musician and the system?
But first of all, this is a huge question, and it's a very interesting question that is currently being tackled by many researchers in the academic community. Sorry, do you hear me? So I was just saying that this is a very interesting question. It is tackled currently by different research in the academic community. This poses several challenges, where what is how this artificial intelligence is modifying our perception of the creative act. Well, my take on it is that artificial intelligence, whatever progress will be, will never be able to substitute the real thing, that is the musician. Also, I strongly believe that artificial intelligence, when it comes to creation, can be successfully used to support the creative process. Of course, there are different companies that are also tackling these issues with excellent results. There are also ethical considerations, ontological and so on. So, in one shot, I can answer to your question saying that from the scientific perspective, I don't think that scientists have the role somehow to answer to this question. But more interesting, I think, is the role of a scientist in identifying which are the right questions instead, that will be tackled by different stakeholders, like the music industry, for instance, academics, and also the society at large.
Thank you.
Thank you.
Thank you, Luca Turchet.
Thank you very much.